Hello everyone, welcome to my channel One Concept Double. This is one of the DC machine question. Here they are asking to draw magnetizing curve. This is DC shunt machine with a field shunt resistance of 100 ohm, including it will act as a regulator as well. They are saying that the field winding will act as a regulator. Will act as a regulator. They are given the terminal voltage is 50 volts when generator running at 1000 rpm. The terminal voltage is 225 volts at 2000 rpm and 405 volts at 3000 rpm. They're asking to find magnetizing curve at 2000 rpm. We already know the magnetizing curve is drawn between generated EMF and field current. Let's suppose this is a magnetizing curve at 2000 rpm. For 1000 rpm, the magnetizing curve will be like this. For 3000 rpm, the magnetizing curve will be like this. Means, let's suppose if we increasing the field current from zero point 0.5 amps, 1 amps, 2 amps, they given the EMF respectively among the curves. Let's go into the basics. Let's suppose the machine is running under no load condition, then the generated EMF is equal to terminal voltage. Terminal voltage. Or if you are assuming the armature current is very small, then IARA drop will be also low. Then in that particular condition as well, we can able to think generated EMF equal to terminal voltage. Now we come into the topic. Like suppose in the terminal voltage of 50 volts at 1000 rpm means we already know E equal to K into phi into omega. Here I am making the field current constant. They given 1000 the terminal voltage among this curve they given. I want to find this particular voltage. Then K is a constant, omega is not a constant. Phi is constant here. I am making field current constant. Then E1 by E2 equal to omega 1 by omega 2. Omega 1 is N1 by N2. Here, terminal voltage is 50 volts, N1 is 1000 rpm. Here, N2 is 2000 rpm. When we need to find E2. By using this formula, I found E2 is 100 volts at a field current of zero point 0.5 amps and speed of 2000 rpm. Similarly, the given terminal voltage of 225 volts at 2000 rpm. We don't the field current of 2.25 amps is giving a terminal voltage of 225 volts at the speed of 2000 rpm and 2.25 field current. Now we go for a 3000 rpm. Let's suppose in the 3000 rpm they are mentioning they have field current some IF3. They given some voltage Vx. In this particular field current we need to find this particular voltage. What is this particular? This is same formula. We are making the field current constant, right? Here I equal to Vt by Rf means we are making field current of 4.05 amps. We know E equal to K into phi into omega. K is constant, phi is constant. E1 by E2 equal to N1 by N2. Here E1 is given terminal voltage of 405 volts and speed of 3000 rpm. This one is given, this one is given. We need to find out 2000 rpm. Then I found that terminal voltage 270 volts at a speed of 2000 rpm at a field current of 4.5 amps. Means at the rate 3000 rpm is generating a terminal voltage of 405 volts at field current of 4.05 amps. Similarly, at 2000 rpm, it giving a terminal voltage at 270 volts. Now we plot these three. This one, this means A, this B, this C. Means we know at the field current of zero point 0.5 amps, we are getting a voltage of 100 volts. Means at zero point 0.5 I am getting a voltage of 100 volts. At the 2000 RPM I am getting a voltage of 225 volts. Means at 2.25 I am getting a voltage of 225 volts. Similarly at a field current of 4.05 I am getting a voltage of 270 volts. Right? This is a very good question in terms of open circuit characteristics. Means they are asking to find terminal voltage at this speed. Terminal voltage means we already explained before, like the generated EMF is equal to terminal voltage at nodal condition. Or where if you are assuming IA or a drop is low, then the generated EMF will be equal to terminal voltage. Then this EA is terminal voltage. At field current of zero point 0.5 amps, the terminal voltage will be 100. At field current of 2.25 amps, the terminal voltage will be 225. At a field current of 4.05 amps, the terminal voltage is 270 volts. This is a very good question. This sort of question, please subscribe to my channel.